Welcome learners to this session on environmental chemistry. In the previous session, we discussed about tropospheric pollution caused by gaseous air pollutants leading to global warming, a phenomena similar to greenhouse effect and acid rain. In this session, we will explain about the particulate pollutants and stratospheric pollution. Under particulate pollutants, we will discuss about smog, formation of photochemical smog, effects of photochemical smog, and how can photochemical smog be controlled. In stratospheric pollution, we will deal with the formation and breaking of ozone, the ozone hole, the effects of depletion of the ozone layer. So, let us begin with the study of particulate pollutants first. The particulate pollutants are the minute solid particles or liquid droplets in the air. These are present in vehicle emissions, smoke particles from fires, dust particles and ash from the industries. Particulates in the atmosphere may be viable or non-viable. The viable particulates, for example, bacteria, fungi, molds, algae, etc., are minute living organisms that are dispersed in the atmosphere. Human beings are allergic to some of the fungi found in the air. They can also cause plant diseases. The non-viable particulates may be classified according to their nature and size according to the following 4 types. First one is smoke particulates. These consist of solid or mixture of solid and liquid particles formed during the combustion of organic matter. Their examples are cigarette smoke, smoke from burning of fossil fuels, garbage and dry leaves, oil smoke, etc. Dust is composed of fine solid particles over 1 micrometer in diameter produced during the crushing, grinding and attribution of solid materials. The sand from sand blasting, sawdust from woodworks, pulverized coal, cement and fly ash from factories, dust storms, etc. are some typical examples of this kind of particulate emission. The mists are produced by particles of spray liquids and by condensation of vapors in the air. Examples are sulfuric acid mist and herbicides and insecticides that miss their targets and travel through the air and form mists. Fumes are generally obtained by condensation of vapors during sublimation, distillation, boiling and several other chemical reactions. Generally, the organic solvents, metals and metal oxides form fume particles. The effects of particulate pollutants are largely dependent on the particle size. Airborne particles such as dust, fumes, mist, etc. are dangerous for the human health. The particulate pollutants bigger than 5 micron are likely to lodge in the nasal passage, where the particles of about 10 micron enter into lungs very easily. Lead used to be a major air pollutant emitted by vehicles. Leaded petrol used to be the primary source of airborne lead emission in Indian cities. This problem has now been overcome by using unleaded petrol in most of the cities of the India. Lead interferes with the development and maturation of red blood cells. The next kind of particles are smog. The word smog is derived from smoke and fog. This is the most common example of air pollution that occurs in many cities throughout the world. There are 2 types of smog, classical smog and photochemical smog. The classical smog occurs in cool, humid climate. It is a mixture of smoke, fog and sulfur dioxide. Chemically, it is a reducing mixture and it is also called a reducing smog. Photochemical smog occurs in warm, dry and sunny climate. The main components of the photochemical smog result from the action of sunlight on the unsaturated hydrocarbons and nitrogen oxides produced by automobiles and factories. Photochemical smog has high concentrations of oxidizing agents and is therefore called oxidizing smog. Now, coming to the formation of photochemical smog, when fossil fuels are burnt, a variety of pollutants are emitted into the Earth's atmosphere. Two of the pollutants that are emitted are hydrocarbons, which are coming from unburnt fuels, and nitric oxide, that is NO. When these pollutants build up to sufficiently high levels, a chain reaction occurs from their interaction with sunlight, in which nitrogen oxide is converted into nitrogen dioxide. This NO2 in turn absorbs energy from sunlight and breaks up into the nitric oxide and free oxygen atom. You can see this in the figure here. Oxygen atoms are very reactive and combine with the O2, that is oxygen present in the air, to produce ozone. The ozone formed in this reaction reacts rapidly with NO gaseous formed in the first reaction to regenerate NO2. The NO2 is a brown gas and at sufficiently high levels it can contribute to haze. You can see this in this reaction. Ozone is a toxic gas and both NO2 and ozone are strong oxidizing agents and can react with the unburnt hydrocarbons in the polluted air to produce chemicals such as formaldehyde, acrolein and peroxyacetyl nitrate, which is also commonly called PAN in a short form. You can see about the structures of these compounds here. Now, coming to the effects of photochemical smog, the common components of photochemical smog are ozone, nitric oxide, acrolein, formaldehyde and PAN, which we have just said. The photochemical smog causes serious health problems. Both ozone and PAN, they act as powerful eye irritants. Ozone and nitric oxide irritate the nose and throat, and their high concentration causes headache, chest pain and dryness of the throat, cough and difficulty in breathing. The photochemical smog can lead to cracking of rubber and it can also cause extensive damage to plant life. It also causes corrosion of metals, stones, building materials, rubber and painted surfaces. Now, the question which comes to our mind is, how can photochemical smog be controlled? Many techniques are used to control or reduce the formation of photochemical smog. If we control the primary precursors of photochemical smog, such as nitrogen dioxide and hydrocarbons, the secondary precursors such as ozone and PAN, the photochemical smog will be automatically reduced. Usually, catalytic converters are used in the automobiles which prevent the release of nitrogen oxide and hydrocarbons to the atmosphere. Certain plants such as Pinus, Xaniparus, Quercus, Pyrus and Vitis can metabolize nitrogen oxide and therefore, their plantation could help in this matter. After understanding the tropospheric pollution, let us now see what is stratospheric pollution. Here we will explain the formation and breakdown of ozone, ozone hole and the effects of depletion of ozone layer. Coming to the formation and breakdown of ozone, you know that the upper stratosphere consists of considerable amount of ozone which protects us from the harmful UV radiations which have lambda 255 nanometer coming from the sun. These radiations cause skin cancer, that is melanoma in humans. Therefore, it is important to maintain the ozone shield. Ozone in the stratosphere is a product of UV radiations acting on oxygen molecules. The UV radiations split apart molecular oxygen into free oxygen atoms These oxygen atoms combine with the molecular oxygen to form ozone. Ozone is a thermodynamically unstable and decomposes to molecular oxygen. Thus, a dynamic equilibrium exists between the production and decomposition of ozone molecules. In recent years, there have been reports about the depletion of this protective ozone layer because of the presence of certain chemicals in the stratosphere. The main reason of ozone depletion is believed to be the release of chlorofluorocarbon compounds, which are also known as freons. These compounds are non-reactive, non-flammable, non-toxic organic molecules and are therefore used in the refrigerators, air conditioners and in the production of plastic foam and also in the electronic industry for cleaning computer parts. Once CFCs are released in the atmosphere, they mix with the normal atmospheric gases and eventually reach the stratosphere. There in the stratosphere, they get broken down by powerful UV radiations, releasing the chlorine free radicals. Now, this chlorine free radical can then react with the stratospheric ozone to form chlorine monoxide radicals and molecular oxygen. The reaction of chlorine monoxide radical with atomic oxygen produces more chlorine radicals. Thus, the chlorine radicals are continuously regenerated and cause the breakdown of ozone. Thus, CFCs are the transporting agents for continuously regenerating and generating chlorine radicals into stratosphere and thereby they damage the ozone layer. The ozone hole, a very familiar term. In 1980s, the atmospheric scientists working in the Antarctica reported about depletion of the ozone layer, which is commonly known as ozone hole over the South Pole. It was found that a unique set of conditions was responsible for the ozone hole. In summer season, the nitrogen dioxide and methane react with chlorine monoxide, which was shown in reaction 4 earlier, and chlorine atoms in reaction 5, forming chlorine sinks, which prevent much ozone depletion. Whereas in winter, special type of clouds called polar stratospheric clouds are formed over Antarctica. These polar stratospheric clouds provide surface on which chlorine nitrate formed gets hydrolyzed to form hypochlorous acid, as is shown in the reaction here. It also reacts with hydrogen chloride produced as per the reaction 5 to give molecular chlorine. When sunlight returns to Antarctica in the spring, the sun's warmth breaks up the clouds and HOCl and Cl2 are photolysed by the sunlight, which is shown here in the reactions below. The chlorine radicals thus formed initiate the chain reaction for ozone depletion as described earlier. Now, coming to the effects of the depletion of the ozone layer. When ozone layer gets depleted, more and more of the UV radiation filter into the troposphere. UV radiations lead to aging of the skin, cataract, sunburn, skin cancer, killing many of the planktons and damage to the fish productivity. It has also been reported that plant proteins get easily affected by the UV radiations, which lead to the harmful mutation of the cells. It also increases evaporation of surface water through the stomata of the leaves and decreases the moisture content of the soil. The increase in the UV radiation also damages the paints and the fibers, causing them to fade faster. Now, let us sum up what we have learnt in this session. We learnt about the particulate pollutants and the stratospheric pollution. The particulate pollutants are minute solid particles or liquid droplets in the air. The particulates in the atmosphere may be viable or non-viable. The The effects of the particulate pollutants are largely dependent on their size. The airborne particles such as dust, mist, fumes, etc., are dangerous for the human health. Under particulate pollutants, we discussed about smog, formation of photochemical smog, effects of photochemical smog, and how can photochemical smog be controlled. In stratospheric pollution, we dealt with the formation and breaking of ozone, the ozone hole, and the effects of depletion of the ozone layer. Now, it is the time for you to answer some questions. Do you know what is haze? Find out more about it. What is the difference between common smog and the photochemical smog? What are the types of UV radiations which can affect us, and how the depletion of ozone layer can cause damage to many more things. We hope that you have enjoyed learning from this session. We thank you very much for being with us.